Welcome to this new tutorial. I will be explaining one application of neural networks. In this case, it will be digit recognition. The last simulator I made of a 3D neural network simulator used digit recognition, and I will be explaining this project because some people ask for a tutorial of digit recognition. So, as you can see in the background image, you are seeing a 3D implementation of a neural network. In this case, I didn't do it, but I will show you one I made with Unity. So, now I will be explaining how this will be working and why it will be using neural networks. Firstly, we'll have here an image of a tube, for example, and we are doing the training, okay? So we'll get all the pixels of this image, and it will be of width and height m by m, and with these pixels we'll assign them into a matrix. This matrix will have the positions of the pixel for later rendering each pixel. This matrix will be then converted into a linear array of m dot n of length, and we will assign this p array to the first input layer of our neural networks. In this case, I have used for the inputs, because of the fact that we are using a 28 by 28 image, we'll be having 784 inputs. Then we'll have two hidden layers of 20 neurons, and finally the output that will be the predictions from 0 to 9. Also we'll have the bias, as you can see here. We have here the bias, and we have also the full connected layers. So how we'll be updating the network? We'll do the feed forward, okay? We'll have the input values. In this case, it will be from 0 to 1, depending on the grayscale, because we have images of 28 by 28. Okay, and this image, it will be only white and black. So if it's black, it will have a 0, and if it is white, the pixel will be 1 input. If it's a gray, a tone gray scale, it will be a value between 0 and 1, a float value depending on how gray it is. So we'll all end when we have the values of the input layer and the biases. We'll do the feed forward to the neural network. It will activate each neuron, and it will have these values that you are seeing here. And finally, it will give us the prediction. So the prediction, if it is more than 0.5, we can assume that the neural network think that it's a good candidate of being that solution. So if this is the 0, 1, 2, 3, 4, and to 9, the 0 will be activated, the 1 no, the 3 yes, and finally the 4, the fourth neuron, that is the 3, will be also activated. But we know that the solution must be a 2, because we are using reinforcement learning. We'll know the solution, and we know that the correct solution is the 2. So we'll do the backpropagation. We'll calculate the error with the desired outputs, because we know this must be a 1, okay, because this is the solution. This is false, 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 okay. So if we have here 0.8, okay, we'll need to compute the error doing the mean square error that I explained in the previous video. And with here, we'll need to do 1 minus 0.5 square. because this is the only that is the correct prediction. So when we calculate the error, we need to do the propagation, and finally we'll update each bias and wave to improve the network. Okay, so we'll do the backpropagation and we'll update the network. And finally, when we have learned a lot with a lot of examples, when we try a two, this two or a different two, we'll do it and we'll have the correct prediction that you are seeing here. We have 0.1, 1, 9, and 1. So the 9, the neural network is saying us that the the correct value or solution is the 2. That is correct now. Now I will show you some important parts. I will show you the code of this project, the 3D neural network that you will be seeing now in the window. If you want to click it, you can go to it to see the simulation. So as you see here, this is the most important part. We have different classes. Firstly, we have the IDX loader that it will get the train dataset that we want to get, and also we have the digit image that is the image that has the level that is the solution and the pixels of the image that will be our inputs. I tell you that we need to convert it from a matrix to a linear array that you are seeing here. Okay, then we have the matrix class. This is a simple matrix class. It has the most important things: two constructors, a random field matrix for the weights initialization, transpose, that is important, the multiplication of two matrices, the add function, and finally we have all the get methods and the print matrix. Okay, now we'll be seeing the most important class, that is the neural network. Here, as you are seeing here, we have the width, okay, and also we have the height of the image, that are the pixels. These all are the parameters of our neural network. Also we have the settings, the most important settings, that are the max random value weight, okay, that is the value that will be having the initialization. Here if it's 1, it will be from -1 to 1. Also for the biases, also we have the bias learning rate and the learning rate. You can change all these parameters in the Unity editor here. Now we'll see the structure of our neural network. You can assign the hidden layers. In this case I have 3. The size of the hidden layers of the neurons, the size of the input layer, and the size of the output layer. And we will calculate the layers in the private field. Then we'll have all the activation functions that we can assign to the layers. Then we'll have all the list of our weights stored. We have the neurons, the out neurons, the net neurons list, the wave, that is important, and also the deltas, the error signal of our neuron weights and neurons, and finally the biases. Also we have for the graphics, because we are using an engine, we have to store the game objects of the project. We have to list for the weights and the neurons. Then we'll have the settings of the layer, because each layer will have a byte that is one of these activations, and it will be the activation in layer. that we see in the previous video, the sigmoid and the ReLU and others. Then we have the panel that will have also assigned the game objects. Is the panel that you are seeing the pixels and all the UI stuff. So now here we update the weights. Okay. Well, firstly, here when we start the program, we assign all the values. We create the arrays of the local biases. We'll fill all the neurons, biases, and matrices, um, and all that stuff. Then we'll initialize all the graphics that you are seeing here. We create the cubes, the spheres, the meshes, and all that stuff, the shaders and the render. And here we create all the lines that connect the neurons, that are the weights that you are seeing here. And finally, we create here the panel of the digits that we are currently updating and testing. We have here the activation. If we want to activate, we need a matrix and the positioning layer. Here we can return the activation. Okay, we will, depending on which activation are we using, it will do the function that is assigned to this activation. So this is the important method. It's a thread, a separate thread that will be our Unity editor executing. It will carry the epochs, the training sets that we can get from the IDX loader, the epoch, the iteration, and these are the UI where we want to update the information. So we'll iterate through all the epochs and then through all the training sets, and we'll do all the important stuff. Update the inputs, the feed forward, get the error, render the panel of the image, changing the colors and updating everything, updating the weights also, and finally doing the backpropagation. And we'll see now the render panel. This is simple. We iterate through all the image and change the colors depending on the values. This is for updating the inputs with some values. We put the inputs in the neural network, the error, the mean square error, that is simple. Getting the outputs. And here is the most difficult part, that is the backpropagation. We need to have the desired outputs. And we'll do all the stuff of the delta. I have explained the math behind the neural network. The biases, we do all the weight variation, and finally we'll print all the important stuff. And we'll need to do in the output layer, because we say that is different from doing the output than in the hidden layer. And that's all. Hope you find useful this video, and see you in the next video.